Hello. For this video lesson, we're going to look at u-substitution, excuse me, again, except this time we're going to have some boundaries. So we have definite integrals instead of indefinite integrals, and the issue is, how do we handle those boundaries? There's two different ways to do it. I'll show you my preferred way and the unpreferred way. Either of them will get you to the same place, so it depends on what you like. So we start with just looking at this as an integration problem with a u-substitution. I'm going to assume that you've already become pretty skilled at u-substitution from with the earlier practice. So now I'm not going to talk you through this, but what I am going to say is the boundaries go from 1 to 2. Those are x boundaries. So if you are going to change to a u function, then you're going to have to change your boundaries into terms of u. So when x is 1, u is 2, and when x is 2, u is 5. So instead of going from 1 to 2, we are now going to bound from 2 to 5 of 1 over u squared du, which is nice and integrable. And we, at this stage, we can put our u boundaries in the right spot. So that's actually really handy because I don't have to go back to the 1 and 2 anymore. When I do my calculations, I end up with 3/5, which is 0.6. Checking with Desmos, a definite integral, I also get 0.6 between the same boundaries between 1 and 2 of the given function. So I feel really good about this. My u sub got me there, and it got me there in a nice, efficient way. Now, what some people choose to do is they ignore the boundaries when they integrate so that they end up with this integral right here. Then they go back, and I have it back in terms of x, so then they take the original question and write it as an integral in terms of x with the boundaries originally given from 1 to 2. Notice that if we do that, we still get the same values, that is 3/5 or 0.6. So it doesn't matter how you slice it. But the reason I like writing the boundaries in terms of u right away is we never have to switch back from u to x. We're done. Or if you don't do that, you have a tendency to kind of maybe get lost along the way. So trust me when I say that we should just switch our u boundaries right away, and then we don't have to think as hard throughout the remainder of the problem. We're going to get the result directly rather than indirectly. Another quick example, we have a nice easy u sub thing here, but our boundaries are what's going to make this different. We're going from -1 to 1. So when u is -1, or sorry, when x is -1, u is e to the -1, or 1 over e, and when x is 1, u is e to the 1. So there's a nice, super easy u substitution here, and we get an easy trig integral, and then we just evaluate from e to 1 over e, which is, again, very simple calculations. We get an approximation, and whether you check with Wolfram, which gives you a nice exact answer and an approximate value and shows the graph, whereas with Desmos, we only get an approximate answer, not an exact, but we do get a graph that looks the same. So feeling good about this. Last example. Square root of the tangent of x times the secant squared of x dx. Once again, we can see a u substitution candidate in here perfectly. But as a reminder, once we make our u sub, we evaluate tangent of 0, and we evaluate tangent of pi over 4. So we change our boundaries from 0 to pi over 4 into 0 to 1. Again, easy peasy integral, and now that I have the boundaries in terms of u, I just sub those in, and you can see this is so much easier than what I would have to do. If I didn't do this over here, I would have to go and switch this back so that it's actually 2/3 of the tangent of x to the 3/2 power, and then I'd have to put in 0 and pi over 4. You can see it becomes less elegant when you do it that way. And once again, the affirmation of putting this into Wolfram and finding the 2/3 exactly as I wrote it, that feels great. So don't forget to check your work electronically. Thanks for watching.